You might want to pause the video now to take a look at what is the difference between this column of graphs and this column of graphs. What happened before and after, what happened before and after, and so on and so forth. Do you notice that the graphs are the same except for the front part being chopped off? See that? Spot the difference? So for this type of graph, what happens is in this column we have all the function signal, and in this column when the front part is chopped off, it's because of the switch function, the unit step function. So type 1, we are going to find out how to sketch unit step function with a signal in front. Basically, the idea is to have the original signal function, which is the ft, drawn out, and subsequently incorporating the unit step function, we will just have to take off or switch off the front part. So let's now go into detail. This function is simply a horizontal line of 1. So this shows that the front part has been cut off and the signal only turns on from 2 o'clock or time equals 2 onwards. So this is represented by ft ut minus c. Therefore, in this case, ft, the original signal is 1, so in this is a 1 ut minus 2. Or I can simply just write ut minus 2, 1 is redundant. Similarly, this original signal function is a horizontal line at 5. So as you can see, the front portion is chopped off and it only switch on at 1 o'clock onwards. So we write this as the original signal function 5 switch on at 1 o'clock. Now, this we need to know the original signal function, but it's a linear function. So how do we know what it is? Since it's linear, it's called y equals to mx plus c, but instead of x replaced by t time, we need to find the gradient m and the y-intercept c. But it's very clear to me that the y-intercept is 2. So now I'm going to find the gradient. Now there seems to be a missing information here where when t equals to 1, what's the value of y? So let me just fill in the missing information now. When t equals 1, y equals 3. So with this, I will be able to find the gradient. So let me take this point, which is labeled 0, 2, and this point, which is labeled 1, 3, to compute the gradient, which is y2 minus y1 and x2 minus x1, which gives me 1. So this linear line, this function here, is called mt plus c, where m is 1. So 1t plus c, where c is 2. So notice that the front part has been chopped off at t equals to 1. It switched on. So this with the switch is called t plus 2, which is the original function, original signal function, incorporated with the switch at 1 o'clock. For more examples, here I have a y equals to t squared function, original function, and you can see that the front part has been chopped off at time is 2. So the original function is t squared and incorporate the switch which is at 2 o'clock. Here, this is a waveform. It's a cosine waveform. So the original signal function is cos t, and you can see here it has been switched off, turned off, or chopped off, and only turned on at pi. So let's take the original signal function and incorporate the switch with switch ons at pi. Now these are the type 2 graphs. So once again, you can pause the video for a while and try to spot the difference between the before and the after. Now, do you notice that in this case, it's chopped off not just in front but also behind? See that? But here, it's chopped off behind. In this case, in front and behind. So how are we going to represent these graphs by unit step function? These are the graphs with the original functions on the before, and after they are actually chopped off in front and behind, so they have a switch at the beginning which represents on, and another switch later which represents off, because there's a subtraction here which means kill off the signal. So in this case, we chop off before and after, which means chop off in front and chop off the back portion. So let's go into detailed explanation. In the first graph, this function is a horizontal signal at 5. So in this case, the front portion is chopped off because it will only turn on at 1 o'clock. After which, the back portion is also chopped off because it turns off at 2 o'clock. So I can write this function as 5, turn on at 1 o'clock, and kill off at 2 o'clock. In the second function is a cosine function. Now in this case, is it chop off in front? Doesn't seem to be, but we can still write it in this way. We can think about it as turn on at 0. Immediately at the y-axis it has turned on. But at the back, you can see that it is switched off at pi. So we kill off the signal at pi. So we could write this simply as ut instead of ut minus 0. Next, in the third example here, I have a linear function. So to find this linear function, it is y equals to mx plus c, but it's not x in this case, so mt plus c. So I need the gradient and I need the y-intercept. It's clear to me that the y-intercept is 3. So let me find the gradient. Let me pick this point, which is labeled 0, 3, and let's pick this point, which is labeled 3, 0. So you just need 2 points to find the gradient. So the gradient can be computed to be y2 minus y1 and x2 minus x1, which is negative 1. So this original function can be written as mt plus c, where m is negative 1, negative t, plus c, where c is 3. So now I'm going to chop off the front because it only turns on at 2 o'clock. And I'm going to chop off the back because it turns off at 3 o'clock. So this original function, minus t plus 3, Let's turn it on at 2 o'clock and kill it off at 3 o'clock. This is the last type of graph. Pause the video for a while and see if you can spot what happened before and after. Now, do you notice that the graph has been shifted? Actually, they look exactly the same, but it's shifted right. Shifted right. Same here. The graph looks exactly the same, but it's shifted right. So this graph has been shifted right. So what happens is all these original signal function, we call them ft, which you can also call them ft ut. Ut means this function starts at the y-axis. Can you see all these functions starts at the y-axis? All these functions starts at the y-axis. So perhaps it's better to look at them this way rather than this way, although both works. Now what happens is they have been shifted by some amount of time. So we say they have been shifted means both these t, let's shift them by c to the right. So therefore it becomes t minus c ut minus c. Let's look. So for the first example, I have a cosine function. So if I were to write it this way, because this cosine function starts from the y-axis, I will write it as cos t u t. Now I see that it's been shifted to the right. It looks exactly the same, just shifted by how much? Let's see. This is pi. Let's suppose it's shifted by pi by 2. So function cos t ut shifted by pi by 2 to the right. So instead of writing t, I write t minus pi by 2 ut minus pi by 2. This represents shift of pi by 2. So I have this t square function, which I will write as t square, which starts at the y-axis, so t square ut. And now I look at this shifted graph. Shift by how much? Shifted by 2. So I'm going to take this and shift by 2 as well as shift by 2. So I will write it as t shift by 2 square ut shift by 2. So this type represents the shifted graphs. So with this, I'm going to complete the examples in the lecture notes.